car is born. Saving energy. That's the motto of the 80s. But when building a new car, it's also a matter of increasing safety, reducing noise and exhaust emissions still further, and increasing passenger and driver comfort, although these aims often conflict with energy consumption. The task of the car manufacturing industry is to produce a vehicle adapted to our needs, but at the same time to give due warning when self-contradictory regulations are imposed by law. Even before the design team is commissioned to conceive the outward and visible shape of a new car, the technical concept, the equipment, the cost factor and the weight have largely been predetermined. The times are past when designers could just give their imagination free rein. Today, an unbelievable number of regulations and restrictions have to be taken into account. The visions on the drawing board have to be discussed item by item. Most important, their technical feasibility has to be established. These checks are facilitated through computer technology. Conflicts are inevitable. Thus, fuel consumption, vehicle weight or air resistance can only be reduced to a certain level, since demands for safety, comfort, luggage space and visual appeal must also be met. And finally, when designing a new model, one aspect is vital, retaining the company image, which enables the mark to be instantly recognized. The designer's job is to develop a personal formal language, combining two things, conformity with legal and technical requirements and an aesthetic appeal to the prospective customer. Stylistic ideas are presented with full-scale precision in a one-to-one styling model. After model approval, the next step is detailed vehicle design. Measurements are taken by computer and stored for construction on the screen. The first detailed plans of the styling model are also drawn up to actual size. Using computer-based design methods, the surface shape is built up in detail. The designer can execute all the constructional steps on the screen, check his design, as here for example on the front wing, to any desired scale and observe it from all sides. The constructional design is complete as soon as the drawing for the milling cutter path is established. These lines show the exact path the milling cutter has to travel when producing the original shape. The advantage of these measuring methods, there is a direct data connection from the styling model right through to the press tools. The milling cutter follows the path prescribed by the data. To guarantee consistently high stylistic standards, quality checks in each new work phase are indispensable. To manufacture the press tools, a prototype press tool is necessary. It is checked against the car body data and serves as a standard checking control for all subsequent manufacturing equipment. Deviations are shown on the EDP list. Before a new model goes into series production, prototypes and experimental models are tested. To ensure greatest possible safety for passengers and driver in the event of a collision, the designers have provided the car body with crumple zones at front and rear. The reinforced passenger cell itself thus becomes a safety compartment. Computer measurements make it possible to determine exactly at which points profiles or sheet metal have to be reinforced, and also where they can be made thinner. In this way, the weight of the car body can be reduced without making safety concessions. In the wind tunnel, not only is the air resistance measured here, it is also established how sensitive the car is to crosswinds, how great the lift force is, how well the ventilation system in the passenger compartment functions, the engine and aggregate cooling system can be checked, brake ventilation too, and a lot more besides. In the climatic test tunnel, the effects of high and low temperatures are examined. Here, artificial snowstorms can be produced. The aim is to find out how engine and ignition react to dry or damp cold, and how quickly misted over or iced up windows and windscreen clear. Why do we keep on designing new cars? Changes in consumer taste and fashion may play an important part. But the main impulse is provided by the numerous technical innovations and improvements in the sectors of safety, performance, economy and comfort. No car factory can produce by itself all the parts which go to make up a car. At BMW, the birth of a new car doesn't really start in Munich or Dingolfing. Before a single screw can be fitted in the factory, raw materials, semi-finished parts, sheet metal coils, and a lot more have to be made available. A great quantity of outside supply parts come from BMW's own manufacture and from many other suppliers at home and abroad. Over 7,000 firms supply individual items and elements, machines and material. 2,000 tons in all per day arriving at Munich. The majority by road transport, 1/3 by rail. All parts supplied from outside, above all parts where safety is involved, such as shock absorbers, track rods and wheel rims, are subjected to severe material tests before they go onto the assembly line. Sheet metal rolls or coils go to the press shop, 1,000 tons per day. The car body drawing presses have a pressing force of between 200 and 2,000 tons. They cut and shape the sheet material in several work sequences. The sheet is cut into parts of various sizes, depending on whether it's needed for the car bonnet, a door or a boot lid. The process is largely mechanized, although there are still pressing lines which are manually fed. Manual work too on the eccentric presses and the fabricated sheet works. Here car body parts are made, mainly of sheet cut-offs. For the car body shell of any one vehicle type, over 700 different pressed parts are required. When building the car body shell, the individual pressed parts are first assembled and welded into unit assemblies. Today, this is done by industrial robots. These are flexibly programmable gripping and fitting devices with a high degree of automation. In this way, high quantity throughput and high quality standards are achieved. Furthermore, these robots represent a significant step forward in the direction of reducing workload and improving workers' safety on the job. The front section and bottom plate are joined to the rear section. Following all the major manufacturing stages, inspectors check the quality and precision of the parts and the work. The car gets a plate with an identification number, important since in basic car body construction around 40,000 variations are possible per vehicle type. So the car is now marked down for one particular customer just the way he wants it. Step by step, the car body enlarges and develops into its final complete shape and is then welded together. Automation at BMW is most fully represented in car body shell construction. 92% of all the welding is already done by robot. Only they allow flexible automation. One advantage, quicker reaction to necessary parts alteration, for example, when a model is modified. To give additional strength, a number of important joints are hard soldered. The brazing solder gives a high degree of sealing and of strength. Every 54 seconds, a car body is born. At full capacity, this means 2,000 a day in Munich and Dingolfing. When the doors and the boot lid have been fitted, the car body gets the final touches. Solder bumps are ground smooth, joint gaps and contour joins are checked and corrected where necessary. The car body is now finished and is moved to the paint shop. A car should, of course, be weatherproof. The body is given a coat of zinc phosphate, thoroughly cleaned, and then gets its first coat of primer. In this electrical process, introduced a few years ago, the water-soluble paint adheres to the car body surface. Activated by electric current, paint particles also form an even layer in the vehicle's interior hollow spaces, and so provide additional rust protection. Since the car must be watertight and resistant to stone chip damage and corrosion, it is additionally sealed in the subsequent processes with polyester vinyl chloride at all critical points. Now follows the second coat of paint, the filler coat, applied electrostatically. The paint particles given off by the rapidly rotating bells move through the invisible electromagnetic field and adhere to the car body. The paint film covers all the edges and forms a smooth layer all over the body. Before the final coat is applied, the surface has to be thoroughly checked, polished and cleaned. The top coat is sprayed on. Each of the three coats is burnt in a dryer at a temperature of up to 190 degrees centigrade. Now the car body is finished. After a final inspection, only interior hollow space conservation remains to be carried out to guarantee 6 years rust protection. At the same time as the outer shell, the heart of the car, the engine, is being made. Crankshaft, camshaft and cylinder block arrive in the form of forgings and castings. Processing is by means of interacting machine tools, some of them working fully automatically. Until the required quality is finally achieved, up to 75 work processes are necessary. No engine may be assembled without all its parts being subjected to continual checking. At regular intervals, engine parts are taken off the assembly line and examined in the micro-measuring department. The criterion of measurement here, to 1/1000th of a millimeter. BMW's own foundry produces those parts of the car engine that, for reasons of lightweight and heat conductivity, are cast in aluminium. Today, each new BMW car contains up to 30 kilograms of aluminium. It's used for cylinder heads, sumps, gearbox housings, and air suction equipment. Assembly of 4-cylinder and 6-cylinder versions. Depending on model and country of final destination, about 350 variations have to be provided for. Many inventors and technicians have tried to develop an alternative to the Otto engine, tried and failed. Since there will be no alternative in the foreseeable future, the aim remains optimum development of this type of engine. BMW offers car engine regulation under the name Motronic, developed in cooperation with Bosch engineers. Fuel injection and ignition are controlled by microprocessor. The requisite programs operate according to demands made on the engine, to the RPM and to the engine temperature. When the engine has passed its 20-minute functional test, the gearbox is fitted. Finally, the aggregate rolls automatically into the storage unit. There is a continuous flow of components, from the car body plant via mechanical assembly, engine, axle and gearbox assembly to the final assembly point. An enormous range of transport problems is involved, from the miles and miles of transporting chains under the workshop roofs to the conveyor belts in all production departments. To make one BMW, 100,000 different parts must be brought together in accordance with the construction program. The work must be harmonized. Where 2,000 cars a day are produced, 200 million parts have to be moved. Without electronic data processing and a network of data stations, this flow of material would be uncontrollable. Production is tailored to demand. Customers' individual wishes are converted into production orders. All important data are stored in the computer center. From here come the directives: which car, which type, what equipment, which engine, which battery the customer requires. Seat covers and carpet color, a dashboard with or without computer, manual or automatic gearbox, 100,000 variations are conceivable. Computers ensure that the numerous parts and individual items of equipment arrive punctually at the assembly point. Thus, different model variants for various countries and customers can be assembled on the same assembly line. Plastics are manufactured in Landshut. Here, around 100,000 individual parts are made daily for the inside of the car. For example, door linings, headrest covers and dashboard panels. Final assembly entails the highest degree of manual work. Research is going ahead on the development of robots equipped with tactile and optical sensors, but jobs like these will remain difficult to automate in the future. Manual work is above all required where craftsmanlike quality and comfort are called for, in the seat-making department. When the engine and gearbox have been called in from the computer store and the pre-assembly of engine unit and front axle is complete, the whole assembly is lifted into the finished car body. The car now runs for the first time under its own power. On the axle test bed, wheel track and camber are checked and adjusted to ensure proper road holding. There follows a run through all the gears and a check of engine and gearbox functions. Finally, a check of the brakes. Comfort and safety are also ensured with the aid of electronics. For example, through Motronic, the ABS system, fuel consumption display, check control, service interval display, and onboard computer. In designing a car, economic considerations are not everything. Equally important is the achievement itself of designers, engineers, and technicians. They are responsible for the technical know-how, for perfection, and thus in the end for the quality of the product.